yesterday. Yesterday we tried to kind of give an intro, give a kind of a demo of an interesting application while trying to making sure that the environments were set up. And it was probably a little bit confusing. So one thing I did last night, and you probably should have all received an email, there was a gentleman who suggested, hey, you got the reg list, you got our emails, just send it to that. Brilliant idea. And so Aaron did that last night. I published the content from yesterday, and I also published the things you'll need today. They're on the wiki, and so I'll just spend a second showing where that is. And I also got some feedback about slow down. Now, so I'll tell you, I'll try and keep it clean. There's an old bull and a young bull standing on a hill. And down in the pasture, there's a whole bunch of cows. And the young bull says to the old bull, let's run down this hill and meet a cow. And the old bull says, no, let's walk down and meet them all. So I'm going to try and walk down so we cover it all. So again, if I go too fast, I kind of get a bit zippy the mouth on the thing, so slow me down. So here is, hopefully the URL is probably a bit small. So it's, if you go to the wiki, the base wiki, not the VPP subpage, but the root wiki.fd.io, there's a link for events. Under events, you'll find content. Under events, you'll see dev boot, you'll see content there. Under here, these are the presentations from yesterday. And what I did is I pulled out the specific links of things that are going to be helpful for today. I'd encourage you just to take a minute and grab those. These are some of the scripts that we'll be needing, and I'll walk through those and do them with you when we get to that section. This is the GDB init file with some things that I'll be using during the walkthrough, and the breakpoints that we'll be using. And this is a high-level chicken scrawl of init. When I was actually going through and walking the code for what actually happens when we construct a graph, when VPP starts up, what are the things that happen? I started writing down all the various function calls and what talks to what, and I was putting it all in text form on a slide, and I realized, well done, Burns, you've just reproduced backtrace. Okay, so let's stop that. And I'd really looked down at my piece of paper, and I'd drawn it all out as a graph, and went, okay, let's put that up. And so that's a bitmap. Now just note, that's not meant to be, when you click on this thing here, the high-level chicken scroll of init, that's not meant to be exhaustive UML documentation of what's going on. That's just me walking the code, writing things down, and deciding to throw it up electronically. So depending on my energy level and focus, some things have more detail, some have less. But it is a true representation of what talks to what when. So that may be useful, and I'll be actually not referencing that doc. It's something you may want to follow along with, but I'll be using GDB to go through that as well. So you'll have two things to use, okay? Some of the feedback we got was, let's get some more visual content, so there it is. And by all means, good way to contribute. If someone wants to make it more accurate and fleshed out, have at it. I can give you the link to the draw.io file. So far so good? Okay, so I'm going to kick on then. Does anyone need a minute for this, or is everyone happy? I can move on with the preso. No nods or smiles. Okay, got enough nods that I'm kicking on, and no vehement objections. So, the preso. So, what I wanted to talk about here was the data, what I consider kind of Dataplane basics. So what is this? Well, that's just a random bunch of scroll, and it's not meant to mean anything. And I bet you that if you were thinking, this guy's a Cisco networking kind of developer type, what would be the first thing he would test if he just developed a feature? When you convert that into bits, it looks like that, and you're probably seeing, wow, that looks a lot like a Wireshark trace. And in fact, yes, it is a ping. So why go through all that? Well, on the wire, and when I start talking about networking versus communications, it is all bits. We all know that, that's obvious. And the thing that gives it context is the template that we slap on top of it, right? And there's standards for this, and that helps us understand what protocol we're talking and how to interpret the bits and give them context. But there's a layer beneath that that's far more important, right? So here's our Ethernet header. We can see that our IP header, our IP header's here. And we can pick out individual source address and destination address, and this is going to become important, obviously, later on. We can see these hex representations in the debugger. But why is that important? So networking is itself, whether they're IPv4 or 6, just IP packets, they're the atomic unit of transmission. Right? They're table stakes, right, on the network today. And they're stateless. Each packet doesn't really know anything inside that packet about any other packet on the network. It really doesn't. It's the things that interpret those things, the network elements, that impart state. And you can have various heuristics that you can use to do this, but by and large, the corollary is that if these things are stateless, they're therefore connectionless. Right? So what is that? Why is that important? Well, technically, some of the applications that ride on top of these things, where we use HTTP as the next level of protocol, they're connectionless too. When you read the HTTP spec, it is connectionless, but it relies on a reliable transport, of which it doesn't say you have to use TCP. It actually says it relies on a reliable transport. And so there's some corollaries there, that TCP is connection-oriented. We have our three-way handshake, you have relative sequence numbers, window sizes, and it's more of a nod to, and I'm not anti-TCP, please don't take that from this, but it's more of a nod to when networks had high bit error rates and you wanted to know that this datagram was going to reach the thing it was intended for, even if that involved retransmissions. Right? And I want to be able to send a certain amount of information and not worry about things like MTUs and stuff like that. So we have segment sizes. Right? And we also have the ability to kind of throttle things back, sawtooth algorithm. But UDP is not. So it might be reasonable to assume if you have some communication, if I want to communicate with you, if I'm a workload, whether I be an app, a container, a VM, if I want to communicate with you, and I have something very important to send, that I should use TCP. And it's the only reliable way to do so. But that's just not so. Right? And here's the example that I tend to use is ECMP. And the reality is that in absence of failure or congestion, right? So true, right? TCP will retransmit packets when they're dropped or they don't show up. It will retransmit them, but many applications also take that into account and handle the state of their communications as well. And that in the absence of failure or congestion, right, that it's likely, and I'd say almost a certainty, but I'm just caveating, but from an infrastructure standpoint, for the life of a communication, these patterns are reasonably predictable. So what's a communication? So I draw a distinction between communications and networking, in that communication is the desire to share information between workloads, and that networking is the implementation of that. Now, one could just as easily see a world in that if I knew I was co-located on the same machine as a different workload, why not just do DMA? Right? And there's even parts of the Linux kernel in InfiniBand stack, which is RDMA, right? It was really interesting stuff. So networking is an implementation of the desire to communicate. So whether that's connection-oriented, whether it's TCP, or connectionless, and some might say unreliable, UDP, is kind of irrelevant because things communicate and they have a desire to communicate. And for the life of that session, right, these patterns are relatively predictable. So even though in ECMP, and we're talking about specifically here on top, well, actually it would apply to any equal cost multipathing, right, whether it's L2 or L3, right? You hash based on typically some part of the header, and typically it's source and destination, right? You're talking about some form of communication. At L3, right, you're going to be hashing on source and dest, hopefully, right? So if those things are relatively constant, for the life of that communication between that particular, the thing that hash resolves to, it's going to use the same link. These things are relatively predictable on a per interface basis. Now, when we start talking about overlays, and I was chatting to someone about this the other day, when we start talking about overlays, we're no longer talking about a nice distributed array of address space, right, when you have workloads. Because when I collapse those down and I encapsulate those things in an overlay tunnel, I'm now talking network element to network element. And sure, you can do some things in terms of, if you're talking about VXLAN or UDP type encapsulation, you can do some things with source-based port hashing, right, because they're free bits. But not always, right? And you can't guarantee that. So by and large, these things tend to be predictable, right? And we kind of leverage that. So the long story is, and just a little bit more on UDP, because this is interesting. And I'm not necessarily a bigot on UDP, but it is becoming more and more and more predominant in the internet. And so I've got some attribution here. I got a lot of this from Kata. I've already talked about VXLAN. So VXLAN uses a UDP encapsulation. Voice RTP is a UDP encapsulation. In fact, on the internet, it's grown from, in 2005 or 6, from 5% of the internet to sum total by byte traffic, from 5% of the internet to recently 10%. But this bit in red is the most interesting bit to me, is that UDP is now often responsible for the largest fraction of flows on a given link. So now we have these communications, right? The number of flows. I'm not talking open flow, it's just a form of communication, right? Source desk pairs or 5-tuple or what have you. UDP is the largest number of flows on a link. So these communications are becoming more and more irrelevant whether it's TCP or UDP. It's still IP is the atomic unit, and they're still very predictable. So why is that important? Well, self-similarity. So self-similarity has kind of grown from where we originally started with concentrators. Back when I started networking, we had 10-base-5, and I was actually one of the guys who was responsible for doing the vampire taps on the little yellow mark on the big thick bit of cable, because that's where the standing wave was. And so we've moved on from CSMA CD type networking to collapsing that down into I have my own collision domain on a per link basis, to now I actually have an entire layer 3 domain at my disposal on a per workload basis. Now, why is that important? Well, as these workloads become more and more self-similar and they become more distributed, and we start getting more into the world of the 12-factor app, which you can go ahead and Google anytime you want. It's part of the fundamental philosophy behind Kubernetes, is that these workloads and microcomposition, right? So we start to split applications up into smaller and smaller functional units that unitask and do one thing and one thing very well. Those communication patterns are going to be more and more predictable. And we have a whole slew of these containers that are all going to have their own connected link. And as perhaps even using things like IPVLAN, right, where we actually get rid of a lot of the broadcast requirements, the traffic patterns on a per interface basis are going to get more and more and more predictable and more self-similar. So what does that mean to VPP? Cool story, bro. Why do I care? Well, self-similarity is actually an artifact of communications, not networking. It's irrelevant whether it's TCP or UDP. It's more about the desire of the workload to share information with another workload. And as these workloads start to decompose into containers, and those traffic patterns from container to container are going to be far more predictable, and we can leverage that. So even though VPP at its core is a processing engine that leverages vectorization to get far greater performance, pipelining, right? And we have the whole networking implementation details of the RFCs and what the context of the bits mean. We leverage the fact that we understand communications and this self-similar predictability. So we expect the best, but be prepared for the worst. Meaning, if the last packet, and we'll go through this when we decompose the max swap example in a graph node. If the last packet P0 went to, and these are actually bits and pieces from the max swap graph node, if the last packet went to this node, let's just warm up A, the next node for this packet, right? Ouch production. We get things ready. We start sending it on. We presume it's a presumptive warming of the next node, but that's expecting the best. But be prepared for the worst. And so Dave, when we get to that part, I'll go through how we actually do prefetch and set everything up to go get that packet ready for the next node. If we're wrong, Dave will go through that section of code that actually makes sure that the packet gets to the right place. Because if you just presume that it's going to go to the next node and you're wrong, and maybe a way of handling that is to drop it and count and check for a retransmit, that's terrible. When Marcek goes through his CSIT numbers, there's a thing called the non-zero drop rate. It's a little bit like the official IETF, or RFC, excuse me. The official RFC definition of non-drop rate is a little bit like the acceptable levels of rat feces in food, right? There's so many parts per million which are okay. Well, not here, right? We have 0 rat feces, right? We do not drop packets. So how do we do that and still be able to use a presumptive prediction of, if I sent it here last time, it should be okay to send it there again? Well, Dave will cover that, right? How do we make sure we get well? In real networks, we actually do a lot of predict trues in the code, right? So we know that more than X percentage of the time where X is a large number, this bit of code is going to be executed. So let's just make sure that the compiler knows to predict true that and make sure that this is a single inline block of code that gets put into the iCache when that node is called, right? We need to handle the corner cases, right? But we can optimize things, reducing ouches, right? And we also use hardware classification results to DPDK, right? We take leverage a lot of the stuff that comes out of the DPDK metadata. So that was it. We're going to take a break now, but that was just a high-level view of what I think about the data plane, right? We have a whole lot of networking type things where you can go and read books about what IP is and TCP is. You can read RFCs. You can implement the RFCs, but at the end of the day, there's real-world heuristics that are involved that we can leverage and do leverage in VPP. And there's some of the things that we're going to be getting into as well this afternoon. And so that may explain why we're choosing such a trivial example as max swap, because we don't have to deal with a whole bunch of different things that are very implementation, RFC specific. We can deal with the mechanics around how do we use predictive or presumptive fetching of the buffers, right? What are some of the looping structures that we use? And how do we get well if we send it to, if we made a wrong presumption? Fair enough? All right, so max swap. So this is the example application we'll be working through as part of the debugger and explaining how graph nodes work. So very simple, we're basically going to be taking the ingress, source and des MAC, and swapping them and spitting them back out the interface they came in on. So in terms of the type def, we have a struct for the Ethernet header that we'll be leveraging, and this is a direct comment from the code showing that this is not the fastest way to swap a MAC address. But again, we're not looking for the most elegant algorithm, we're looking at all the bits around it, right? So why bother with this? Well, we want to talk about the code structure, and we'll be getting into that in the next slide. Talking about complexity versus complication. A bunch of very simple, well thought out things that you can pose up into bigger and better functionality. We'll be going through the vector functions, and so they're the things that we care about in the graph node and the things that we want to understand. We'll be going through in the node, we want to focus on the dual loop algorithm. We want to focus around how to wire it into the graph. We'll be going through that diagram I linked on the wiki, as well as some of the debugging key breakpoints and showing how things actually get wired into the graph. Probably later on, maybe not today, more than likely tomorrow morning, we'll then talk about, now you've got your wonderful all-seeing, all-dancing graph node, how do I then create a CLI for it? And more importantly, an API. We'll be talking about the distinction between both and potentially an open source project, if anyone would like to kick it off around that, as well as tracing. Tracing is obviously huge, and there's quite a bit to that as well. So with that, what don't we have to worry about? We don't have to worry about all the transformations. We don't have to worry about, I just whipped off X number of bytes of this type of header, and now I have to whip on X plus some other value of header and what happens to the buffers, et cetera, et cetera. Let's just forget all that. Let's worry about how things wire into the graph, how do graph nodes basically work from a skeleton standpoint, and then there'll be implications. We can talk about some of the things you can tune when we actually get into the transformations and handing off to different graph nodes, okay? So no deep dives into the fib just yet. Dave's going to handle that on Thursday. So one of the key tools that I like to use, and probably should put this on the, we have it on the reporting, we have a how to report a bug page that I covered yesterday, and the types of information that are very useful. The other thing that might augment that is when you email the list and say, hey, I've got this problem, one of the first things we talk about is, is there basic communication before we start putting in overlays? The other thing is every host that we'll be using has TCP dump. So capturing TCP dump and storing it somewhere is quite helpful. So Wireshark is our friend. We'll be using that quite a bit. I use it all the time, just to prove about what I'm sending in and sending out. So I thought what we'd do is probably start with, actually I might skip this bit. we might just start talking about the code, and we'll come back to it before we hit the debugging session, because I don't want to necessarily break the flow. I thought it would have been a good idea to start, let's build the skeleton out and then start talking about the general code. But what I'll be talking about is more the libraries in general. So we might save this bit for when we actually start the debugging session. And that way everyone's kind of got their laptops up, terminals up, and that'd probably be more appropriate to hit it then. And we definitely need to do that before we hit initialization, because what we're going to be building is for that graph node in the max swap is a plugin. And I want to be able to show in the debugger the differences between the compiled nodes and when we see those initialize and a plugin initialize, and then show you the actual graph construction and how there really is no difference between the two when it comes to graph construction. So it is important that we have that node built before we do the initialization walkthrough, but probably not for this point. And I might leave that slide up over lunch to give people a chance to kind of do it over lunch. Probably seems like a reasonable kind of compromise. So in terms of the code, these are the main directories, and I've highlighted what I consider the most important ones. Build root is a whole bunch of utilities that Dave, or a section of the code where everything is built. Dave can probably cover that in more detail if folks have a deep interest in it. Obviously, we have a dpdk directory, but the three big ones that we'll be covering in this session are vnet, vlib, and vpp infra. So on the right, what I'm showing is the number of commits since this got moved into the Linux Foundation. That's LF. So I'll use LF and Linux Foundation interchangeably. Since the project was moved into the Linux Foundation, when was the Git repo pushed up, Dave? Sorry. Okay. So since the 1st of February and up till this commit, which Pierre did. Pierre, quick, raise your hand again. There he is. Oh, he's got headphones on. Just say hello. Yeah, very good. Back to sleep, mate. I know. I can barely see you with my specs on anyway, so it's all good. Anyone could have put their hand up and I was going, oh, thanks, Pierre. These are the number of commits per directory. So why would that even be relatively important? Well, you can see the vast difference in magnitude between VNet, VPP, and VLib. I'll be breaking down VNet, VPP, and VLib, or VPP infra, sorry, in a lot more detail. But the point of showing you this is where you'll be spending most of your time hopefully doing features is in VNet. You'll be leveraging the facilities that are in VLib and VPP infra. And that's not to say that if you see something wrong there, you should fix it or that you can't make changes there. But by and large, this stuff is relatively stable and should be things that you leverage. But I'm going to go through those and hopefully you'll see that. But by all means, if you find a problem, fix it. But most of your time is going to be spent in VNet. So let's start at the bottom, VPP infra. So the first thing in VPP infra is types.h. Now I'm going to keep, hopefully the people at the back can read down the bottom here. If not, I'll just refer to it. And if I need to, I can switch to the code itself. But types.h is where we define a whole bunch of types you're going to see. So if you go through the code and you see things like I8, I32, this is what they refer to. That's just to keep things consistent. There's actually a couple of other types. Like uword specifically is as wide as a pointer. On some platforms that may change. So we just generically refer to uword and iword. In cache.h, we have some precompile macro. The main thing in here that I consider important is the cache line width, right? So here it's set to 6, which is 2 to the 6, 64K. There's some other things in here too, but by all means dig in and have a look. Now in vector.h, so we have vector.h and vec.h. So in vector.h, we define a bunch of types that are actually for when you're leveraging the SIMD instruction set. So here, I've tried to put a graphic out here, considering you may have a 128-bit register, we can have 16 by 8 bits, right? Or 4 by 32 bits, or 2 by 64 bits. So we define a whole bunch of types for leveraging there. So when you go through the code and you see examples there of this particular type, that's pretty much what it's for, right? But these are not the vectors which you seek. The vectors that we're really interested in are the vectors where we're actually processing packets, or vectors which might make up graph nodes, or that may make up the graph, or vectors of various things for which we have utilities. So in vec.h, the numbers here representing like the grep count. How frequently do these things show up in the code? So the theory would be that if something shows up more frequently, it's probably more important, and that's pretty much how I decided where I'm going to focus. These things are all really well documented in comments in the code, but I just wanted to break down some of these ones that I consider the most important ones. So again, vec.add1, really great comments in the code, but vec.add1, and you'll see this pattern show up over and over and over again in VPP infra. And that's this idea that we have something that we called vec.add1, which actually, when we go into the code, calls vec.add1 HA. HA meaning not high availability, but header and aligned. So what it does is it calls the root function, which is over here on the right, vec.add1 HA, and it passes 2 0 parameters. Right? So when I want to simply add an element to a vector, I call vec.add1. I don't care about user-defined headers, and I don't care about alignment, perhaps for this particular use case. So I can still use the root vec.add1 header and aligned function, but it will get called in the background with 2 0 params. Same thing goes when I want to add an element to a vector and I want it aligned, but I don't have any user-defined header. I call vec.add1 aligned to signal this is what I want, but it's really in the background using vec.add1 HA. Again, with this 0 param for the header size in bytes. So it may actually be worth having a look at an example. Any questions on that? Make sense? Vec.add1 means add one element to a vector. And you can go in and have a look here at the vec resize. I might actually get Dave to talk about some of the interesting usages later at the end of the session and I think that would be very useful if you don't mind, because you've been using this for a lot longer than I have around how we leverage things like vec resize, vec validate, how you can use some of the vector functions to essentially do an assert, right? All very useful and often used patterns. The next one is vec.add2, and this doesn't mean add 2 elements to a vector. It's the type 2 vec.add, which really means I'm going to add multiple elements. So again, it uses this common pattern of HA, do I have a user-defined header, and do I need this to be aligned? And by passing 0 params, or zeros for certain parameters, we can reuse the root function. So vec.add2 called just without any, just vec.add2 will call vec.add2 header aligned, where we have v is the pointer to the vector that we want to add things to. P is the pointer to the new vector elements, which is how we can actually add multiple elements to that original vector. N being the number of elements to add, and H is the header size. In this case, over here for vec.add2 is 0. There's no user-defined header and no alignment. And in the aligned version, there's no user-defined header, but here's the alignment that I want.
Yeah. Hey Keith, let me do
Please, mate.
Let me do a sentence or two on the vec.add2 family. Vec.add2 is really, vec.add, again with the alignment stuff, but it's give me a pointer to some number of these things. Well, give me a pointer to some number of whatevers was a little long to type, so it turned into the numeral 2. It's just sort of the second vector add API. There's nothing magic about, well, why is it vec.add2 rather than vec.add3? Well, it's literally, I want a pointer back and I want to be able to allocate, n of these in a n of these in a chunk. Yeah, it could have been that too, but it ended up as vec.add2. If you want to pick on how if you want to pick on a not too awful example, you could look at the ADJ alloc in in VNet. VNet IP ADJ alloc. This is a case where you're certainly using the header. I don't remember if I bothered aligning them or not.
How's my font size there for folks at the back?
Right. Oh yeah. Will reality? Yeah. This is actually an interesting thing to talk through sometime. Over a beer perhaps. But the point here is look for a vec.add2. Yeah. There's the full Monty in use, which basically says I want a block of. I'm looking for, oh, hey, you know what? I've actually got a toy for this. Wait, we have technology if I can find the thing.
Do you have a catanoia?
No, what I really have is a toy that a colleague named Lauren Cooney gave me, which is this.
Yeah, it's a cat annoyer.
Yeah, exactly. Oh yeah, cat annoyer. Okay, I get it. That's in English, American English versus Aussie English. At any rate, so in this case, what I'm trying to do is get a block of n guys, shove them in edge block. I want them. I want a header of this size. Now, the header of these things is actually adjacencies, mumbledy. What did I put in the header? We'd probably have to look at the header file itself to do it. In all probability, it's the free lists for the various sizes. Look for AA. Yeah, free list indices by size. I just saw it. Okay, so it's free lists. Any rate. Let's see. So the VecAdd2HA dude here is literally saying, I'm going to put a header in front of the standard vector header, which has just the current effective size of the vector, and I want the thing aligned. It turns out the adjacency objects want to be aligned. So there's a detailed example of using the most general macro VecAdd2, where I want some number of them. I want a certain size vector header, and I want the thing aligned to a cache line. Just an example off the top of the head.
Yeah, I would have looked for things calling it and tried to find one. That
was
it, but he knows.
There are not that many examples of using the thing in its full glory, but there's one that's actually recent enough. I could probably even explain how it works in a pinch.
Does that hold, Christian? Okay, cool. Sorry, can you maybe speak up?
Oh, sorry. Yeah, well. Oh, yeah.
We need mirrored cat annoyer.
I kept hearing that as paranoia.
If you look at the definition of the macro, the do while, the while zero, meaning that it will only go through once.
Yep.
So what's the reason for having the do while there?
So
not having parentheses accidents.
Yeah.
It's a common macro thing.
Okay.
It's done. Yeah.
Okay, this is for
Semicolon on the end.
syntactical reason, right?
Yeah.
Okay. Okay, got it. Thank you.
Yeah, same reason that we have brackets and parens around things. It's for insertion, so you don't get syntactic errors and order precedence problems in macros and things like that.
Yeah,
Good question.
Standard guitar lick.
Yeah.
And the optimizer deals with it.
Yeah, thanks.
Yeah.
Yes, indeed. The optimizer, and so the statement was that the optimizer deals with it. So we've covered VecAdd1, and as Dave said, VecAdd1, in terms of the number of times that it may be in the code 112 times, but in terms of the code path, it's the IP adjacency side of things is the most predominant call case. And I'm pretty sure when you do the fib walkthrough, you'll be able to go through that in a bit more detail as well on Thursday. We have a question.
I have a basic question about the elements in the vector. So what can the elements be? Is that packet or another vector?
Yeah,
or?
let me do that one. It's an easy one. Literally, any struct type can be done as a vector. The only restriction being, all the elements in a vector are the same size. In fact, the underlying mechanism really sees them as chunks of bytes rather than as foobarts. But vectors are just they're dense dynamic arrays of instances of struct foo. They're nothing real complicated about it. The one thing about vectors you have to realize is that they start off essentially at n equals 1, and they grow by 3 halves, so that you're not constantly calling the memory allocator. But when a vector expands, it gets picked up and moved. So the coding pattern is always memorize indices in vectors, don't memorize pointers. Because if you memorize a pointer, particularly in a hash table, all of a sudden, your code will look like it's working, and then all of a sudden, oh bleep, the entire hash table is useless because the vector, the vector which you've, elements of which you've installed as keys in a hash table suddenly moves, and the entire hash table is just non-compos mentis anymore.
Right.
So you'll see very often the hash set, hash table, key, and then vector, current pointer to element versus current, minus current base. So you just get an index. That's in the code probably 150, 200 times.
Yep.
That's the classic mistake. I had a mail exchange with someone who I'm pretty sure is not here on the FD.io lists about, mumble, 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 and my hash table blew up in my face, and they said, "Oh, did you by any chance put pointers into it?" Oops.
Yeah, and then memorize the pointer and
mea
reference it later.
culpa. I've been a pilot for 20-something years, and one of the jokes in aviation is there are two kinds of pilots: those that have landed gear up and those that will. And doing that mistake with the vector stuff is like landing gear up. Everybody does it eventually. I'll plead guilty. It's one of the little traps with this coding mechanism. On the other hand, I'd like to think it's pretty convenient for the problems at hand. So.
No, it's perfect, thanks. And before we jump into VLib, we might get you to walk through vector resize too, because that was one of the 3 halves things that we...
Well, you don't want to walk too far into that because it'll just make your eyes water a bit, but...
An exercise
it's
for the
one
reader.
of those things. It's one of those things in the beginning of time you sort of say, I will take as a theorem that this actually freaking works, because it does, but you have to stare at it carefully to believe it.
Right. And this is what I was getting at in terms of these compositions of relatively simple things that we leverage and build on and build on and build on. In terms of vec validate, I'm going to have to jump. I couldn't fit all the code on the slide, and I bet you, yep, there it is, vec.h. I actually want... and this is why I'm going to punt to Dave, because I did want him to discuss this in a bit more detail for us.
Oh, why do you validate a certain index in a vector?
Well, the first thing I see is that V can be null.
Oh,
So what
yeah,
does
yeah.
it mean to validate a
Yeah.
null vector?
Yeah, well, the null pointers end up being construed as vectors of length 0, and it's really quite handy that you go if you go check in vec_add1, is this thing actually a null pointer, yada yada. So a data structure, freshly allocated, freshly zapped, if it's full of pointers and they're actually vectors, those count as 0 length vectors. So you say validate this thing, so that index 15 is valid. It'll say, oh, null pointer. Okay, I know what that means down in the guts. It turns out, it's arbitrary, but it's extraordinarily convenient to not have to worry about initializing something and then, then making it a certain thing. It's just done under the floorboards.
Answer your question, Matt? Cool. The next thing is bitmap.h. There's some really cool things inside of here. I got a reference to one of them on the next slide, but obviously you have an array of bits. One of the more useful things is, rather than just using it as a set of flags, if you have something that has ternary state or 4 states, you can just multiply the index. So you can just take lumps of bits, right, by powers of 2. So these bitmaps turn out to be incredibly useful, especially when we start talking around pooling. And again, I'm probably going to jump into Dave again as well for this, because where are probably the most likely places where we use pools? Because I know that it's a very key construct that leverages vectors and bitmaps.
Yeah, pools are very commonly used when you want a tunnel, basically a session object of things that come and go periodically as the system runs for a while. It's a fixed sized object allocation scheme where ultimately, the goal is to not call the memory allocator at all. This code base is designed to build things that run for months minimum, and the last thing you want to be doing is going to the memory allocator every time you want 50 bytes, and then you give back the 50 bytes, and pretty soon, everybody in the room knows you fragment the bejesus out of the heap, and you end up out of memory even though you're really not. Well, the pool allocator is both extraordinarily fast and reduces memory fragmentation to basically 0 in steady state, because you're just allocating and freeing out of a vector, which has been allocated once, thrown down, and that's that. So yeah, pools are really a composition of vectors and bitmaps. That it's a fixed object allocator. We use it all over the bleeding place.
And these are some of the key functions that we use with pooling.
Oh,
and
hey Keith,
the
let me
pool for each
back up.
macros.
Now let me back up to bitmaps for
Oh.
a half a second. One of the more amusing uses you can imagine is, oh, you want to write, you want to ham encode something or do something where you end up with variable size characters effectively. Bitmap's a pretty good way of doing that. That you can output a compressed representation where you're using 2 bits, 3 bits, 4 bits. You just need to know where, what the ending bit number is. You say, oh, gee, plunk down 5 bits, no problem. And if you look at in VPP Infra at this thing called zvec, which I think I left around, even though we're not using it. It's an entropy coding scheme that my buddy Elliot made. I wouldn't necessarily go try and use it, but it's exactly a case where the output function there is doing. It's possible. No, I guess I didn't trash it, but you're going to see that there are bitmaps in there used for output. And if you ever want to do a compression thing just off the side, a bitmap's not a bad way of doing it because it's really easy to output the thing. And then, of course, you just take the view of the bitmap as a sequence of U words and output the the variable with bit fields that way.
Pool for each, and we were discussing this the other day, so I deliberately put this comment in because you were warning me about something, and I went through the code and I decided, yeah, I might go stick this header in there.
Yeah. Yeah, this is a Dresselhausism. My early on chief collaborator in this stuff is a guy named Elliot Dresselhaus, and he worked really hard at optimizing pool for each, and so that it tended to process runs of occupied cells as rapidly as possible. But that macro is not GDB friendly. So in a pinch, what you want to do is to say, okay, I know I'm going to walk this bitmap, and until I get the code compiling correctly, the best thing to do is to make myself a simple vector of occupied indices and then go code the loop I want. Once it compiles correctly, you can kind of get rid of the vector. If you need to step through the guts, the body of a pool for each macro, it's just a little bit of a hemorrhoid. But it's not actually all that common to traverse a pool. You're mostly doing pool put, pool get, pool get index. Oh yeah, and pool else is another one, which is how many active items are there in the pool? Is another thing you'll find.
I was looking for that. Okay, so
yeah,
pool
it's
else.
another one that you might see in the code somewhere. Yeah. While Keith's typing, pool elt at index is a good thing to use versus doing a direct indexing computation, simply because it's going to check to make sure that, for example, you're not playing with an element that's free, that it has off to the side a bitmap, and it's checking the bitmap to make sure that the element that you told it to go get you is actually allocated. Otherwise, you'll get the middle finger, and deservedly so. There are a number of reasons to run debug images, and one of them is pool elded index, vec elded index both do the obvious idiot checks, and I plead guilty to every so once in a while I'll screw up that way. So do yourself a favor for until functional testing and some level of stress testing works, on a code, always run with a debug image. Yeah, they're a factor of 10 slower. I'll stipulate that. On the other hand, they will save you a mint in why the hell did I just get this, bus error, sig v, what on earth happened? Whereas you would have a moment earlier seen an assert that said, oh, hey, dude, that was a free element you just tried to play with, and it's now full of garbage.
Yeah. So that's the example of.
For production, just like asserts that is labeled on production.
Yeah.
You do the same trick for the.
Yeah. That's exactly. Pool elded index is just the indexing calculation in a production image. On the other hand, it goes and refers to the bitmap and makes bloody sure you haven't screwed up on in debug images.
Yeah. Question.
Pool is just an abstraction for memory management.
So the question was, pool is just the abstraction form for your memory management?
Yeah, it's a fixed object allocator. It's just many systems have had them. There's nothing too unique about it. It's just a fixed object allocator, built on top of vectors and bitmaps.
So basically, as a developer, if the only time I use pool is if I'm creating a new.
A new session, a new tunnel, a new whatever. Yeah.
But it's an example of composing things such as the vector functions and the bitmap functions together to make something bigger and better rather than replicating and creating a whole new bunch of structures, right? Any more questions on this? This is kind of important, so if people have questions, this is a good place to ask them.
What?
The question was, what's ELT?
Element. Yeah. Oh, yeah. I started programming back in the days of Fortran 4, and I'm a big, I'm a big believer in the fewer characters you can type. So yeah, ELT is element.
So what's the relationship of the free bitmap and the free indexes?
Oh, great. Yeah.
The relationship of the free bitmap and free indices.
Oh, pool. Okay. Well, let's see. Which? Oh. Yeah. Well, free indices. Okay. There's a bitmap. There's a bitmap of, of free guys, and free indices are indices in the vector that are actually free. In other words, the bitmap is just a single bit that says, index 43 is free. And in order to be able to reallocate 43 rapidly, you don't want to do a bitmap scan. You just peel the last guy off the free index vector. So it's a few instructions versus chunking along in a bitmap. If you have a million things in the, a million things in a pool, it's way cheaper to, keep the 25 that are free out of a million in a dense vector and then take the last guy in the vector. I'm sure if you looked at it, you'd find that how do I allocate a free index is going to be something of the form, veclen of free indices, decrement that by 1, probably by saying under vec under len equals, mumble minus 1. That's the index you want. Then you do a bitmap set, which is, again, it's an indexing calculation in the bitmap vector, so it's pretty quick. The thing you don't want to be doing is a find first set operation on a million element vector where there are like 3 of them free at the end, because you're going to be sitting there chunking along for a while, even doing them 64 at a time. So that's the reason that they're both.
Cool.
It even somewhat made sense, I guess.
Question?
Yeah.
Strange question. So the free bitmap is a U-word star, so I assume that's a 16, U-words is 16, because I didn't get a chance to
Oh,
prep
it's
check.
64.
64.
Okay, so, all right, so U-words 64-bit.
Yeah.
And
Well, actually, the truth of the matter is a U-word is a pointer as wide as the widest integer in the compile model.
All right, so so this will work on all kinds of different architectures then.
Yep.
Yeah.
Yeah, on purpose.
Okay.
And that's actually defined in types.h. So. No, do totally fine. Just want to make sure it's covered. So time in CLib, we could spend quite a lot of time, definitely worth exploring, Definitely worth exploring. Dave can explain some of the times that we step in and use very specific time-based instructions, assembly instructions, and probably why that's important is that we obviously want to make sure, because we do have a lot of stuff that's happening at the assembly level, that all the timing is correct, especially when we get into the event logger and we're measuring things at nanosecond levels, that everything is synced up and we have a reliable time source. Is there anything else you want to kind of say on that? I don't really go into a lot of detail here because they're just there.
To go build a graph node feature,
Exactly. But there is some really cool stuff too in here, and I just have these finger pointer for stuff I just thought was pretty cool. It was the log2 first set.
Oh, that's the X and twiddle.
Yeah. And the how to skip ahead and to get rid of all leading zeros and get to the first interesting bit of something.
Most CPUs actually have a find first set instruction and so on. And this stuff, a lot of it is actually derived from this, hacker's delight, and goes all the way back to HackMem, the 1960s thing done at the MIT AI labs. I plead guilty to having been around that long. And Dresselhaus also is kind of a student of random obscure hacks, like find me how many bits are set in a word. It's good to hear.
Did I skip? Excuse me a second.
You seem to be going backwards.
I am, because I'm missing some slides.
Bad engineer, no donut for you.
Uh-oh. Ruh-roh indeed. I'm missing all my VLib slides.
That bites.
When I split this into 2 decks, it's Google, so I can always go back in the revision history, but then you'll see my use of colorful language. So I'm going to defer to you, Dave. I'm going to put you on the spot.
Okay.
Can you walk us through some of the VLib stuff? I don't mind being your
By
remote
some
mouse.
of the, by some of the VLib stuff, where were you planning to start with all this?
Yeah, I don't have all my content, which is a giant pain in the...
Well, let's take a half a deep breath. Yeah,
Yeah.
let me do a couple of words by way of introduction on VLib, so Keith can go find out his revision history, whatever. Any rate,
It ain't gonna happen, dude.
yeah, I hear you. VLib isn't, VLib is a pretty general vector processing library. It's not specifically targeted doing packet processing. There's a little bit, there's an extent to which the world is a mess and to where knowledge of specific kinds of vectors, to wit, VLib buffer Ts, to wit, DPDK RTM buffs have crept into VLib, but it's not, it would not be difficult at all to use it for general vector processing, to do forward error correction calculations, to do FFTs, to do stuff you might want to do with the vector library, that it's not so, welded at the hip to the network stack you can't imagine, imagine dealing without it. Yeah.
No, and thanks, I know you just kind of giving me air cover there after my screw up. Just thinking on it, I do cover VLib main T, vnode main T, vnode T, vnode registration T in quite a bit of detail during the GDB init sequence of events. So we could probably dive into that part.
Yeah, that's a good plan. And if people need more details filled in around the edges, just holler. I'm here through Thursday.
P-type is your friend, so we might just spend a little bit of time on
go
that.
For it.
Just thinking through some of the most salient parts, because what I just quickly did, this is a breakdown here.
Are you going to do, if you start, the way I've done this before is to walk through the init sequence, because it's important for people to understand, okay, here's how how all the pieces are hung together a little bit.
In excruciating detail.
Well, why don't you start being excruciating then? I'd go for that.
That's one of my
and
core competencies.
Folks, being excruciating or tall or whatever. So, I don't know. I have a bad case of short bald guy disease. What can I tell you?
So we'll go through the init sequence, and in so doing, explain each of the types, how they get made and instantiated, and how the graph actually gets done. So I know a lot of people here aren't necessarily using Emacs. If you're not, one thing you can do is I took the entire plugin that gets generated using Emacs skeletons, wrapped it up into a tarball and splattered it down here. I would suggest what we do now is you stop and SSH into the VM that we're going to be using for VPP, and get this, either you can clone it, or if you'd rather, in a second I'll fire up Emacs and walk through how to build the skell, and we'll do a quick build, and then we'll start on the actual debugging part, and I'll make sure everyone's environment is up to speed, et cetera, et cetera. So I'm going to give everyone a chance just to kind of pull down this last line. Do I need to make the font bigger, or is this reasonably sized?
You need to give me an extra degree of freedom in my neck.
Yeah. You can follow that, and then I will be following it as well.
I hate to tell you, I think you got a typo. I think it's Emacs-Lisp, not list.
Where?
Yeah, I see it. I'll point at it, Keith. Keith?
Oh, yes, thank you. Yes, that is definitely a typo. I'll wait till people are done and I'll correct it. Thanks.
Yeah.
And bless you for paying attention.
Wow.
Well, I wouldn't allow it.
Bless you for trying. That's awesome.
Yeah, the easiest thing to do is just set file to this guy, all-scale.el in that directory, and then do metax eval buffer.
Yep. It's all up there.
It's for all you Emacs heads. I like, again, I need an extra degree of freedom
Yeah,
in my
sorry,
neck,
mate.
so this way nobody gets to see us, see us web surfing.
Everyone okay if I get rid of this slide and go to the terminal? Not yet. But what I can do is come on, little fella.
Maybe you can just
Yeah, mate.
maybe you can just link the pull down.
No. It'll be linked later this afternoon. I could have, but there you go. So it is now linked to day 2, max swap instructions. Okay. No. All over the map. Okay. Oh, why for you do this? There we go. Okay, I'm on branch max swap. I'm just going to stash this so I start from scratch. So I'm pretty sure I'm up to date. It says up to date, but still. I've been here before. There we go, that'll do. Okay. Let me just try and get the mini buffer up to the top of a bit higher up on the screen so folks can see what I'm doing. And I can go back to full screen. Let's see if that's going to work. Yep, okay. Everyone see the last line of the terminal at the back? Should be high enough up. Cool. All right, so as Dave was alluding to before, we do have some pre-built skeletons as part of the project for Emacs users, of which, and now's a good time to fix that typo, thank you very much. Dave and I are both users. So let's open that up. Let's not do that. So it's going to be build root, Emacs Lisp, all scale. All right, so now we have a bunch of skeletons. Now you'll notice in here, there are skeletons for various bits of functionality. You can break out bits and pieces of what we'll be making as part of the plugin. You can pull out just if you only want a dual loop skeleton. We've named these Skell, so you can see that there's a variety of different skeletons that once you've evaluated that buffer that you can choose from just by doing Skell-tab. But for our purposes, what we'll be doing is make plugin. Sorry, question? Okay, question was where are the skeletons? Under the main place that you cloned, build root, Emacs Lisp with a P. Did you get that, mate? Build root, Emacs Lisp. As opposed to build data, there's two directories there.
So, complaint saying that dev boot directory is not there.
If you do the tile one, you have to make dev.
Yeah. If you follow this, it'll create it. And actually, that's a very good point. I forgot a step. Before I dive into this, actually, I've already got one there. Give me a second. Yeah, go away. I should already have a dev. Do I have dev boot in here? I do. So I'm going to make a directory called devboot. Go into that directory and then I'm going to make plugin. Yeah. Everyone so far so good. Sorry about that little snafu.
Yeah.
So basically in Emacs I make sure that I'm in devboot and then I'm going to run make plugin because then it's just going to splat everything down in that directory. Okay? Thomas, you all right, mate?
Is that going to be inside the VPP directory? You made it dev boot?
If you see the directory here that I'm in, shell, it's going to splat it under devboot. So you'll end up with, I'll show you in a second what you'll end up with. So if I do make plugin, it's going to ask what we want to call it, so we'll just call it max swap. Huzzah. So I'm going to save all those. For the Emacs users, Control X, Control S. Now if I get back into my shell, under dev boot, you'll see now we have a max swap plugin directory. Okay? Cool. Getting nods? Perfect.
Cool.
If we go back into there, you'll see that. Oh.
Commonly, the Emacs shell buffer gets confused as to what directory you're in. Do pwd and then cd there, and it'll stop acting stupid.
So I did stuff with the shell, and Mac plugin has the tar, untar of the stuff that you pointed us to before.
Chris just fixed it. I just updated that.
So what?
You just have to make the dev boot. It's just
Yeah.
But I did make that boot. Make it minus P, and then put the Mac swap in there. So I don't understand what.
What are you seeing, mate? Let's have a quick look.
Hey, Keith, you want me to deal with this?
Yep.
Hey, Keith.
Yes.
All you're doing?
No, so there were two, for people using Emacs, this is going to do it yourself. It's going to do it for you, make the max swap directory. For people who didn't want to use that, I created a tar ball for convenience to pull things down that already had the skeleton instantiated. Sorry if I didn't explain that very well.
No, I thought that maybe there was some magic that I was missing.
Not at all.
Nope.
The problem is all mine.
I'm sorry,
Dude, you're fine.
I'm trying to go back and read.
Allie, you wanna give him a mic there? Thanks.
Yeah, if you could explain the directory a little bit.
Try it again.
Yeah.
I couldn't hear the
Yeah.
question, sorry.
No, I think if you can explain the directory a little bit, that there's something like a configure.ac, makefile.am, and maxswap. So what is that? I mean, it happens for every tool, every plugin, or?
Yeah, Dave, do you want to
Yeah,
just cover this?
let me.
Yeah,
How,
oh, well,
how do you build it? Well,
that's
okay.
on the next slide.
Part of the, part of the, the skeleton generator, part of the, the tarball is makefile.am and configure.ac, which effectively is the build recipe for the plugin. And, what you're going to end up doing, is probably auto reconf -i-f to go crank in the stuff, then make a build directory, configure it, yada yada. It's standard auto tool stuff. If you haven't used auto tools, you don't need, you don't have to be this tall to ride the auto tools ride in this game. You just sort of have to be this tall. Literally, Keith's about to tell you the incantation to go get yourself a makefile, which you can then type.
And it's
type go for it.
all here on this slide.
Okay, let's build.
So we need to untar that into /vpp/dev.
Yeah, you need to untar that into /vpp/devboot.
Yeah.
If you want to use the pre-canned tar that I put up for convenience for folks who don't want to use the Emacs Skell.
Yeah. And again, these are just a couple of ways of getting all of the boilerplate splatted down that you need to build a plugin, that you need to build actually even a part of VNet. The difference between, I'm going to a little bit ruin Keith's day by, catching one of his points that he'll make later, is the difference between code built and running as part of VNet versus built as a plugin is negligible, and it's deliberately negligible, so that, how would you put it? You need to have the dev package installed to work purely with plugins and never recompile the engine if you want, as opposed to, a core feature that maybe deserves to be part of the engine. As you'll see, GDB really is completely agnostic to whether something's built as a plugin or not, so it kind of almost doesn't matter. So, yeah. Auto reconf is a piece of the auto tools that, that effectively cooks configure.ac and makefile.am. And what you get out of auto reconf there that's of use is a configure script. And very typically, I personally then make a build directory, cd build, /configure mumble args. We'll let Keith do it his way.
No, it's exactly the same instructions, right?
Yeah.
Is there dot missing and everything?
I'm sorry?
The dot missing and all those things, is it like a dependency thing? Just like Python, when you try to put a Python script or something, it will check all this missing dependency. What are those actually? For example, like dot missing, /missing is installing all this, right?
Hang on. Do you have a problem where it says like configure.a?
Yeah.
Yeah, I think I know what's going on.
Yeah. There's no problem. I'm saying installing, what are they? So what are these, if you can, just go over that. Missing meaning it's like a missing dependency list is doing it. What is it for a plugin?
You
shouldn't get this guy. You
shouldn't be getting that.
Keith's case.
So can someone maybe give this gent a hand with what's going on, because he shouldn't be getting these errors?
I'll do it.
Yeah, thanks, Dave.
Fuck it.
Because, can you maybe just go through, I think the question was really, Dave, around what these, we're getting these configure AC, installing .compile, what do all these mean?
Those are pieces of auto tools. Let's not go there. It's really almost, it's context that's just going to be extra detail.
Right. So they're expected output.
Black magic that eventually produces a makefile would be a good way of looking at it.
Okay. So the next step after auto reconf is to make a build directory, then go into it.
So one question, this folder...
Sorry, there's a question. I'm not seeing who's asking it. Yep.
This folder /vpp/devboot, is it like a new folder that we create, or is it part of the VPP?
Yeah, it's a new folder that we create. This is where I'm just going to install the plugin.
And,
so when we sorry, go
And
ahead.
frankly, that particular place is just for convenience. It could be any directory. When building plugins, you can build them, under a rooted tree anywhere you like.
So this is kind of self-contained, all these make files, and from the plugin, we don't need to connect it to the Git folder of VPP, right?
Correct.
Okay.
No, they're absolutely independent. They can be source controlled.
That VPP, thank you. I didn't even have to run for it. So VPP API gen's not in my path, so I'm trying to figure out which one to use when I type make it.
Well, what you should have, if you've actually installed the dev package, it'll be in, VPP API gen is going to be in a good place.
Well, my dev package never compiled, so I'm just sort of trying to work around that by hand coding the paths and stuff.
Do you need a hand with it? Because we should just get your machine straightened out so you're not having
Yeah, I
trouble.
might have to dump CentOS, and I hate to say it. And
Try playing Stump the Chump with Ed over there.
Looking for a job.
Yeah.
Yeah. Yeah, it's pretty,
Let's just, I'll keep going through the build here. And what time, Erin, what time is lunch?
12.
12. What we can do is probably I'll get through this part, get us to the point where we're about to start doing the debug, stop and just see where people are at and where people need help, right? And just try and get as many folks who want to follow along to the same place, because it is kind of important. There was a lot of expression of interest in how this works, and I think it'd be useful. Question over there?
One thing I am curious about is a lot of the stuff you basically are root all the time. And, eventually, when you've got multiple people developing, they might be sharing the same machine. You don't want all these people running around as root. Is there some reason why you couldn't use sudo here? Or
just lazy, less characters.
Okay.
So
Honestly,
I
it's just lazy. Dave can probably talk this.
I was just curious about it because I noticed even in when I set this up under Ubuntu with VirtualBox, I'm using Mac OS here, but at my work I have a Ubuntu system set up doing this, and I noticed that I did one build. I did it as root, and it screwed things up, and I had to scratch it all and reinstall and come back through. So that was
a bunch more violent than you really needed to be. Essentially, how would you put it? In order to install, the typical flow I use is to run as myself or is to run as non-privileged user, do all the building, then sudo make install effectively.
Right.
Or sudo dpackage -i start@deb.
Right. Well, my point is a lot of the build instructions on the wiki are a little light on at what point you need to be shifting into sudo or to root versus when you can be yourself.
Well,
that's good feedback that we should
That's an absolutely fair point. It's best with the wiki to just go ahead and start wailing on it if you got the time. Don't please don't wait for permission. It's in a case like that where it's just well, go for it, man.
I copied the build instructions to the wiki and I added the sudo step because I never use root.
Okay.
Well, allegedly.
No, thank you. And sorry for my laziness, and if it's anathema to people, I apologize.
Yeah.
And yeah, I am lazy.
Hey, Emran, take a note.
So I'm just going to do the configure step.
What is the command you did?
There.
Or go look at the wiki page because it's in there now.
Thank you.
Okay. You can't do everything.
It takes a village. It's fantastic.
Yeah.
Got that, mate? Cool.
Yeah, you want to do make and then sudo make install if you're running in non-lazy mode.
Yeah.
Actually, one question
Oh.
you could answer.
Yes.
When I'm doing configure this way, is it using the system installed libraries and headers to build against, or is it using the development environment that you're in?
Built this way, you're using the installed headers and libs. Mike.
That's why you're probably the template you have is not fixed. You have an unused variable. That's it.
Yeah, it could easily be
That's because you're using Emacs, apparently.
Yeah, I got all this unused variables.
Where'd you get?
What the hell?
This is, all right.
Come over here, Dave.
Yeah, well, I'm reading. This has got to be, go find the first error. This is going to be one typo, like a semicolon.
Yeah.
Have you not installed the development package?
Yeah, this is the same environment I had MaxSwap installed on.
Okay.
Redefinition of struct.
Hold on. Why don't you just adjourn to the sample plugin directory and fiddle there?
Yeah.
Because this is just, I'll go try it and see what I.
This was working.
I wonder who borked that.
From the wiki, it just works fine.
Yeah, from the wiki it's working.
Well, let's just do that then. I'll work out what's wrong in a break, because I'm like that.
Looks like something got created pretty good. I'm just going to boot my environment and see what's going on with. Yeah. So Keith, why don't you just start talking through some of the parts there?
I'm almost there because I just pulled the known good one I bundled up. Live demos.
So I guess we need to kind of define some environment variables, because when I do the make stage, it complains about missing VPP API gen. So actually, Tom created a link to VPP API gen.
Have you installed all of the Debians? Well, yeah, that's what you ought to do. Is build it, install the Debs.
The initial problem the initial problem I had was that the make RPMs didn't work. I'm working in CentOS, so I didn't get all the packages installed. So VPP is up and running. All the basic stuff is built, but I've got to do all this kind of by hand to work around.
Yeah,
I don't
well,
have some of the tools.
yeah. If you can give us a list of what needs to get cleaned up in the RPMs, we'll go fix it.
It's all happening in real time.
I'm actually using Ubuntu 15 dot something, so that should be close enough to 14 dot something.
Yeah, but if you actually, so this is one of the reasons why we use the Vagrant package, right? There's a bootstrap, Ubuntu bootstrap CentOS, which installs all the build dependencies, installs all the tool chain, all the stuff you need to get this up and running. We could have gone through and gone step by step in terms of setting up the dev environment, but.
Right, but there are some issues with the CentOS build environment.
And yeah, apologies.
And that seem minor issues, but they do prevent you from getting the VPP API gen stuff didn't seem to build right.
Okay, well, let's just continue on a little bit, and then we'll take a break and address folks' issues who have issues.
For Ubuntu command, right, I have installed Ubuntu 15.04 and then 15.10 on Skylake machine, it's working. No problem.
Okay, but just remember the Vagrant files, at least I'm using 1404 LTS Ubuntu, so.
Yeah, It's one thing that's a really good idea is for people to mail somebody a list of all of the various distro versions and combinations, so we can actually start testing them.
Yeah.
You know, because if you hit the 2 or 3 things that the guys here, all 3 of us have probably tested, you're probably not going to run into a problem. On the other hand, I'm not a big CentOS guy. You know, with all respect to Tom there. You know, Ed Warnicki over in the corner is kind of the guy who's done more with the Vagrant Infra than other people, and making sure that we know what to try so that you don't end up with a pain in the backside. And again, if folks find stuff, by all means, change sets to fix them would be appreciated, because this isn't just the guys in the room. I mean, I tend to end up working more to go build new forwarding features than I do on the build infra anymore, even though I know it. So yeah, just let us know.
And I'm definitely not suggesting that anything changed in between when I went through this script and I pulled master this morning and just going through the script now, I got some errors. So at lunch, I'll go through and see if anything has changed or if it's something peculiar with my environment, just to make sure that script is correct. Because I want to make sure that when you leave here and we publish the slides, that the stuff on the slides actually works, would be nice. So, but when I put these slides together, I wasn't just making it up as I went along. I was doing it, documenting. So let me try and work out where these kind of hiccups have come from over lunch. But by what I did do, and thanks very much, Florin, for pointing that out, is that if you do follow these steps here, where are you, Tiger? In terms of this part, that's not going to work. In terms of following these steps here, and just get that tarball down here and get into VPP dev boot, just so we're in a common place. These build steps do work. And that's the stage I'm at now. So I just checked in ls user lib VPP plugins. So the question was asked before, does it have to be in VPP dev boot, which would be, that would be terrible if it was static to dev boot. You can pretty much put these anywhere you want, the plugins. They don't have to be part of the VPP repo. They don't have to be part of the VPP directory structure. You can put them pretty much anywhere, but when you build it, it is placed in user lib VPP plugins, and that becomes very important. That is configurable, but that is where it's going to actually look later on as we go through the steps of looking for plugins and loading the symbols for the initializer. Fair? So the last thing that I wanted to do before we take a break, and so I can at least address anyone's issues that do still have issues, is these steps here, which are also on the wiki. And so the first one is this vagrant net namespace. So the same place that I've been putting the content, I've got direct links to here. It's under day 2. Please have these steps done. Does anyone not have these scripts that wants to follow along?
Can you click that? I think yesterday it was doing some error.
Click this.
Yeah. We'll click my tag. Thanks. Last night it was doing some error.
Well, I haven't changed them.
And then the files had the same links. That it was. There it was. The same links are in Nico's file, I think. There it was.
Okay. Well, they're explicitly linked on the wiki now, so you don't have to go through the slides. So if you have a look there, thanks for that too. Since we just pulled them up. This is the net name. Sorry, Dave, you comment?
As a brain police check, I just ground the skeleton out, compiled it, instant, works.
Okay, so it must have been just a hiccup on my machine.
Yeah, you didn't forget to run configure or something silly, did you?
Don't believe so.
Oh well.
It's possible.
Don't know.
It's possible I had it highlighted on the screen here, thinking I'd done it and pasted it, and
don't know.
All good. But thanks. So therefore, thanks, David. It looks like the instructions do work, all things being equal. All this script is going to do, once you download this script, right, which is referenced here, is execute this So if I was to do it here, because I'm root and lazy, excellent. I haven't pulled it in. Let's do that. It's because I checked out. Let's go to the wiki. Here it is. So here's the instructions I was referring to before. So if we just go and get this sucker here.
Which directory are doing that?
It's going to, if you copy and paste the commands from the wiki here, it's going to tell you -o, place it in, /vagrant, /maxswap. Yeah, it doesn't matter where you execute this.
So your Emacs instructions
Yes.
seem to create the maxswap plugin in the Emacs list.
Yeah, I did say, and probably we're bouncing around a little bit there, go into a shell and make a deb-boot directory and cd into it, because when you actually run make plugin, it's going to use the directory that you're in, it's that Emacs thinks you're in, right? So by pulling up a shell.
Just move it, just, you know.
Yeah.
Yeah,
Just move it under deb-boot.
Yeah, fortunately, it creates a subdirectory, so it didn't just dump all over the place. The first version of that skeleton wasn't so smart, just to warn everyone. And you know, I plead guilty to having whacked that set of skeletons together. You know, could they be better? Absolutely. On the other hand, if treated gently, you'll get pretty much what you wanted out of them.
So when you run the net namespace, yes, you will get. That's because I've already run. Don't worry about. So I'm getting the Ethernet 1 error. That's because I've already kind of absorbed it into VPP. You shouldn't get that. You may get the cannot find device. What it's trying to do is clear things out and then put it back in again. So just ignore that error. But what you should have is 2 net namespaces, right? And you should be able to do IP net namespace exec, VPP1, and see that we.
So where do you have those comments? You have the one which you're typing, right? IP net ns. Do you have that in the wiki?
I actually have it in the decks.
Oh, okay.
So here's an example of, so IP net namespace exec in this namespace, and then standard commands where IP route to, or ping, or what have you, bash even if you wanted to. So do people have the net namespaces created? In that case, you should also see that we have 2 VPP interfaces here for the namespaces. We'll get to the maxswap conf. Actually, so here's a slide that shows you some steps for the environment sanity check. So there's the commands you're asking for. There's just IP net namespace. Bracket doesn't mean take that literally. It's like or optionally, right? So you can do IP net namespace, prove that it's there, then do the exec, etc. We can cat this file for maxswap conf. I think I went through this yesterday. So this is the configuration file that we'll be using from the debug CLI. So this will take those 2 VPP interfaces here, the AF packet interfaces that we created with the net namespace script. It'll be adding them as host interfaces to VPP. On my system, the interface that I stole, you saw the ETH1 error. That's this sucker down here. You can see it has this PCI address 0080. Hence, in VPP, one of the I guess not heuristics. One of the patterns that we use is we take the PCI address and we create this gigabit Ethernet 0/8/0 for this PCI address 0080, right? So I know on my system it's 80. On your system, if that throws an error, you just do lspci and find out what the extra interface is that you should have added in the Vagrant file. But we won't be using that interface until maybe later. So if that's a problem for folks, let us know. And then we just set the interfaces up add some IP addresses, which are the .1s compared to the addresses in the namespace. And then we just do IP probe number just to make sure there's ARP entries for it. So again, if we go, in this sucker here, both addresses, so we have in one namespace, the VPP2 namespace has 172.16.2/24. The interface is .2. On VPP, we're going to give it .1. And in the VPP1 namespace, we're using blah-de-blah .1/24, and .1 is on our VPP instance. So gateway .1 in the namespace .2. So far, so good?